My name is Nemanja, and today we are going to be talking about large-scale topical assignment on multiple social networks. This work has been done by Klout data science team, and Klout got acquired by Lithium, so now I guess part of the Lithium data science team. So first we'll introduce what actually Klout is for those that are not familiar with it. Then we'll go over like problem statement and some of the challenges when dealing with the large amounts of short-form data from social networks. Then we'll look at into some of the system details and the feature engineering. And finally, we'll just look at how do we build models and look at some of the results. So what Klout actually is? Klout is a social influence measuring tool. So usually user comes to the Klout.com, register his social networks, and then on the user's behalf, Klout goes and collects the data from multiple social networks. And in addition to this, we get like a full mention stream from GNIP. So basically we get like a Twitter stream as well for unregistered users. And then using this data, we extract various features and derive Klout score, as well as different topical scores. So what are we dealing with in this setup? Basically, one of the main challenges is being able to process like huge amounts of data on a daily fashion with very limited cluster capacity, right? So every day we get about 650 million new pieces of data. Then we are assigning topics for hundreds of the millions of users across different social networks. And then our topical ontology is like pretty big. It has about 10,000 different topics in it. And all of this needs to be updated in a timely fashion. So we basically recalculate the scores every day. Another set of challenges comes from making sure like we can integrate different sources. So basically making sure like you can collect the data from different social networks, and then even within the social network, there are different types of data you can collect, from user graphs to user profiles and different interactions. And then at the end of the day, you want to create topics which are publicly recognizable. So basically if you put on the public profile set of topics next to somebody's picture, like those topics should be recognized by his peers and not be only like interest of user itself. So some of the applications of these topical assignments throughout the product are one that we mentioned before. Is basically if you come to Klout.com, you can see like the topics that we think you're interested in, and then maybe you kind of are expert in. Then some of the past and the current product usages where basically if you're asking a question, we wanted to have ability to route given topical question to a top influencer that is interested in a given topic. And then also like be able to suggest like who to follow based on topical interest, but also based on kind of the person you're about to follow interest. And then on the business side, we also use like topical assignment to say give free perks to top influencers which are interested in certain topical domains. And then most recently we added like a content discovery feature to the website where basically you can go and browse through, look at the content that is relevant to your topic area of interests, and also maybe like if you're trying to optimize your influence outside the Klout.com, basically you want to be able to look at the content that is relevant on aggregate level to your audience. And then some of the main challenges, as we mentioned before, when dealing with the social media text, is usually you're dealing with big amounts of data, basically 650 million new pieces of data daily, and then on top of that, majority of texts are very short form and they are grammatically incorrect. And then in social networks, a lot of users actually are just very passive consumers. So what they do, they go and browse like the Facebook or Twitter, but not too many of them actually produce the content, right? So that's another challenge. And then in terms of scaling, actually a lot of times you kind of do want to use like sophisticated NLP techniques and kind of do like language understanding and stuff. But in our case, basically if you would to use, let's say Stanford NLP, named entity extraction, and just process like 650 million pieces of the content, it would take about like 82 CPU days. So basically for the NLP approach that we use like on operating on raw text, we actually went with the dictionary-based approach, where you spend a lot of time designing your dictionaries, which are mapping the phrases to entities. And then those entities were a combination of the Freebase, Wikipedia, Klout.com, like DBpedia, and Wiki concepts. So with a pure dictionary-based approach, you could speed up things about like 150 times. So instead of spending 82 CPU days on processing all the data, you spend like less than half a day. And then another benefit of operating on the dictionary, usually like your phrase is mapping to a certain entity, and then entity is a record in a knowledge base. So basically in the case of tweet shown here, Stanford, the named entity extraction was able to recognize the rule of law, but dictionary based approach was able to recognize the rule of law, NSA, and EFF. And on top of that, you had the mapping to the entity itself in a Freebase, which you can use later to say expand the topical context of the sentence using that entity, or use it later for disambiguation. And also, like a lot of time, language models are available only in a limited set of languages, while knowledge bases are much more better scaled in terms of international languages. So one can ask also, like, why do we even care about multiple social networks? Maybe like Twitter has the biggest coverage and has like is most dominant network. Maybe use only Twitter. Well, it turns out like if you use more data, I mean it's intuitive. Basically, you build like a better system. So if you look at even how verbose users are on the different social networks, on Twitter and Facebook, people do kind of share a lot of information and produce a lot of content. But on the networks like LinkedIn and Google+, there is much less content. However, the value of information is sometimes disproportional. So for example, on a Facebook, maybe you talk a lot, but a lot of conversations are not very topical in the nature. They're very casual, talk about birthday or a party or something like that. While on LinkedIn, maybe even if you have 100 bytes of text, you get a very high value information, right? From, for example, looking at the LinkedIn skills. The other benefit of using multiple social networks, so if we look at the right side here, what is the overlap in the keywords across for a same user across different social networks. So even for the most active users, this overlap is at most like 7%. So what this means is basically users usually tend to express different topical interest on different social networks. On LinkedIn, maybe you're expressing more interest regarding your professional life, and then on the Facebook, you're more talking about your personal life. And then how the system looked like. So as we mentioned before, basically we collect data from Twitter, Facebook, Google+, Instagram. We also incorporate like a Wikipedia mappings for the users that have Wikipedia pages, and Instagram as well. And then we collect user activities, user profiles, and user graph information. So those, all that collected data is extracted to the text features. After that, we project text feature to the topical feature, and then we do like a normalization of topical features, where basically for a single user, like we map all the feature values from 1 to 0. And then we train the data on the ground truth, and every day like we basically calculate the scores using the trained model. And after that, basically like topical assignment gets different applications throughout the product. So system details, like we are using pretty much what everybody is using around the valley. Like we use like Hadoop, we store our data on HDFS, and then we use like Hive and for serving HBase. And Hive showed to be like pretty useful because it gives you a couple of things. One is like it gives you like a data catalog, so you can kind of put your features every day in a new daytime partition, put them by the feature name, and basically neatly organize them. And then on the other side, like you don't have to write map reduces. So one HQL query basically just worries about the data transformation. So instead of writing like 3 map reduces with maybe 2 secondary sorts, you're writing 1 HQL query, and it just does the things you want. And on the other side, you're forced to encapsulate like a complex like to say like modules, like let's say like a language detector or name entity extraction into the UDFs. So by design, you kind of have to design these modular pieces, which are going to be later reused throughout the different pipelines. And then we train machine learning models occasionally, like once a month we update them, and then build scores once a day. And then on the side of the resource, how much resource this is taking. So the total pipeline takes about like 66 CPU days, and then the reads and writes are on order of terabytes. Okay, so a little bit about the feature engineering. So for every user, we basically store basically username, and then like we have like a feature name, and then for a given source and the user, we have basically bag of topics, like a vector of bag of weighted topics. And then particularly important thing was making sure like we can use as much context from each piece of the data. So basically, as we said before, a lot of users are basically casual consumers, and then not too many generate. So that's why we kind of introduced like this attribution into the feature naming, where, for example, if you're original author of the post, like we say, okay, this feature is generated. This feature it was generated by you. So we encode like a generated into the feature name. If you, let's say, reacted about like on the original post, then topic of original post is assigned to you in a reacted way. And then if you, for example, haven't done anything to be assigned with the piece of content, let's say you're Obama and you got listed on the Twitter list, basically we say like this feature was credited to you. So it's similar like with the mention, right? If somebody mentions your name, you actually didn't do anything to kind of get mentioned, but still that piece of data is attributed to you. And finally, we had like a graph attribution as well. So in the feature naming, like the encoding we use, basically we would capture like the network, the data source it came from, optionally the time window that the feature is applicable for, and then finally attribution. And the idea was like that it's very easy to add or remove new features, because oftentimes if you spend too much time investing in a single feature, you kind of run out of the time, and then you don't get time to experiment much. So in this model, we would basically constantly add or remove new features. And then the ground truth. So usually, like one of the main problems is like how even to get the ground truth. And in this case, basically, it's not as easy, because like you need to, like for a given social network user, which may be like a high influencer or not high influencer, you need to be able to label some topics. So we built like a small web tool where basically all the employees within the Klout could go, and then we would display them their first degree like an audience. So basically Twitter, people they are following on Twitter, or maybe like their Facebook friends, and then we would give some first guess topics for those friends, and then people, the evaluators would just go and mark topics as kind of positive, negative examples, or skip them if they're not sure about the interest. And then the data set consisted about 32,000 data points, and a total of about 750 users was evaluated. So finally, like we transform the data to the data points where you encode like a topic, user, and then for a given user you have like a feature vector of different features mapping to different values. And it turns out we calculate the precision, recall, and coverage for different features, and it turns out like some features are really good. They have very high coverage, like for example Twitter graph-based features, but then on the precision side they are not as good, like maybe like about 30%. And then on the other side, you have features which are very good, basically like Twitter lists. If somebody lists you on a given topic, like it's a very good signal, but they have a low coverage. And then on the other side, like Twitter turned out to be like a much better signal than the Facebook, which does make sense because on Twitter people kind of tend to broadcast their interest, and information is much more topical. So the final precision of the system was about 60%, and then the recall was about 80, like, which seems like pretty low. But even if you look at the evaluated data set, like if you ask a couple of different evaluators to evaluate same person interest, the agreement is only about like a 70%. So there are like a problem limitations just because like it's very objective thing, asking if, hey, is this person interested in this topic? And F1 was, I think, about 0.65. Cool. So some of the examples of like topics assigned to the users. So these are kind of like a power users, but everybody knows about them. Like Marisa Mayer, Yahoo, Google Technology, then Lady Gaga Music, Lady Gaga Celebrities, Obama, Politics, Affordable Care Act, and Healthcare. And you can see like there are some like outliers here and there, but in general topics look pretty decent. So at the end, like by combining different social networks and different data, we were able to build like a pretty comprehensive system. So we are able to assign topics to the more users than you would be able to assign to any individual network. And then for a given user, we were able to assign more topics just because like we combine more data sources for him. And then just like for fun, we can look at different distributions of the super topics across different networks and see that, for example, on Twitter, the most dominant topics are technology, entertainment. On Facebook, it's entertainment followed by technology, lifestyle, food and drinks. On LinkedIn, on the other side, it's business and technology. And on Google Plus, again, like it's technology, and Wikipedia is dominantly about the celebrities. So key takeaways, like oftentimes people get stuck like hedging a lot of bets like on a single feature, but basically if you want to build like a comprehensive system, you need to kind of build it so you can include as many features as possible. So in this research we had about like finally like 50 features, and throughout the course of the project we experimented with 100 different ones. So so basically, and then like this is just like a question of topical interest, and the harder question is about topical expertise. So being able to assign something like a Klout score, but within the topical domain, where you're building like a global rank of people within the topical domains. And hopefully we get a chance to talk about this some other time. And if you like this presentation, you can check out the original paper. It was presented at the KDD 2014. So, any questions? Yeah. Topic, yeah, ontology. Taxonomy, yeah. So there is only like 3 layers. Yeah, like there is super topic, subtopic, and then entity level. What do you call entity level? Yeah, and it's not the ideal. It's mainly like because of the product decisions that have been in the past.
Is it built based on something like a Yahoo directory or whatever?
No, like we have in-house library specialist which kind of curates and keeps it up to date. Yeah, yeah, because it coordinates with the product and the business team.
And when you say the user text in the comments, you match keywords to your taxonomy?
Yeah.
Identify which topic.
Yeah, exactly. Yeah. And the text themselves, the lexicon is mapping to the freebase concepts. Yeah. So the ground truth, so basically like what we did, like we built like a very small in-house tool. So you would be able as employee, because we know like what are your like first degree connections, like you would be able there to go and see your friends. So basically very quickly you would be able to switch across your friends. And then for each friend, we would show something like this. Basically, we show a list of topics that user is potentially interested in. So you can go like and very quickly just click on the side and mark it as positive and negative example. And basically using like the tool evaluator could go and maybe like in 2 minutes mark about like 50 topics for a given user and then just repeat it for different users. So very quickly you can kind of go through it. But it was very important that actually it was a first degree connection. So person knows the other person. And that's why like mechanical Turk, for example, wouldn't work as well.
Yeah, and if it's based on what users say if users say in different contexts, say watercolor.
Yeah.
If I'm not interested in
Yeah, exactly.
do you still pick this as a topic?
Yeah, so basically that's a very good point. Like because the approach taken here is to big degree like a brute force, right? You're taking and you're doing like entity extraction, which is based on the dictionary. And you're not taking too much language understanding into the context. But the idea is like if you include a lot of data sources, like hopefully, the data sources reinforce itself. So if you said somewhere once like water polo, like maybe it's gonna float on the bottom. And basically that's why at the end like you get a good system. And actually the precision on the top 20 topics assigned, if you sort them by the score, by the linear regression score, logistic regression score, it was about 80%. So 1 in 5 is kind of. So in this, how many ground truth data or? Oh, how many raw data? Well, we try to use as much as possible. Yeah. So that's the last one. Yeah, we can continue conversation. Cool. Thanks.